The problem is from GATE 2021 mathematics paper, question number 2. The problem given is, let f of z given as f of z equal to u of x comma y plus I times v of x comma y for the complex number z equal to x plus iy in C, where x and y are real numbers, be a non-constant analytic function on the complex plane C. Let ux vx and uy vy denote the first order partial derivatives of u of x comma y, that is real part of f of z, and v of x comma y, that is equal to imaginary part of f of z, with respect to real variables x and y respectively. Consider the following two functions defined on C. g1 of z equal to ux of x comma y minus I times uy of x comma y for z equal to x plus iy in C, and g2 of z equal to vx of x comma y plus I times vy of x comma y for z equal to x plus iy in C. Then the four options given are: option A, both g1 of z and g2 of z are analytic in C. Option B, g1 of z is analytic in C and g2 of z is not analytic in C. Option C, g1 of z is not analytic in C and g2 of z is analytic in C. Option D, neither g1 of z or g2 of z is analytic in C. So from the four options we can check, you can see that it is asked to check whether g1 or g2, which one is analytic, where g1 and g2 are given in terms of the partial derivatives of u and y, where u and y are the real and imaginary part of the analytic function f of z. The only hypothesis given is the function f of z is analytic and non-constant. So the NPTEL reference to solve this problem is module 2 lecture 3 of complex analysis. The title of this lecture is Differentiation by Professor T.A.S. Sri Krishna. He is from Department of Mathematics, IIT Guwahati. And even you can watch this lecture using this YouTube link. So now coming to the solution. The only hypothesis given is f of z, that is given as u of x comma y plus I times v of x comma y is analytic in C, complex plane. Then we know that if whenever f of z is analytic, we know f dash of z is also analytic. So by using the similar argument, we can say f double dash is also analytic and f triple dash is also analytic. So in the same way, we can say all the higher derivatives of f are analytic. But to solve this problem, we don't need about the remaining derivatives. We just need about the first derivative, that is f dash. So we have f dash is also analytic. But what is the derivative of f? But we have the derivative of f given as f dash of z is given as ux of x comma y plus I times vx of x comma y, or it can be written as uy of x comma y plus I times vy of x comma y. This is the derivative of f. So now by using any of these conditions, we solve the problem. Since we have the function f of z is analytic, so that means the real and imaginary parts of that function f satisfy CR equations. And of course, those two real and imaginary parts are harmonic functions. That is, since f of z is analytic in C, so u of x comma y and v of x comma y satisfies the CR equations, Cauchy-Riemann equations. That is, we have ux equal to vy and uy equal to minus vx. These two equations are called Cauchy-Riemann equations or CR equations. So now by using these two equations, we check whether G1 and G2 are analytic or not. So we have the function G1 is given as G1 of Z from the problem as ux minus iuy. Ux of x comma y minus I times uy of x comma y. And since u and v satisfies the Cauchy-Riemann equations, that means these two equations. So from these two equations, we can say uy is nothing but minus vx. So by just replacing that, we get g1 of z as ux of x comma y plus I times vx of x comma y. And this is nothing but the derivative of the function f. By the definition of derivative of a function, we can see f dash of z is nothing but this. So since we have already seen, whenever f of z is analytic, we have f dash is also analytic. That can be seen from the reference, that can be seen from the references. So we can say, so g1 is nothing but f dash, or let me write g1 of z, g1 of z equal to nothing but f dash of z. And since f is analytic, so f dash is also analytic. So G1 is analytic. So now we can say some options can be discarded from the given options. But of course, we have to check about the G2 function also. And it is given that G2 of Z as Vx plus Ivy. Vx of x comma y plus I times Vy of x comma y. This is as given. So now we have to check G2 of Z is analytic or not. So for that, the necessary condition to satisfy is the real and imaginary part of the function G2 of Z should satisfy the CR equations. That is nothing but Cauchy-Riemann equations. And so let's check whether these two functions satisfy Cauchy-Riemann equations or not. So for that, since it is already the partial derivative, so let me just rewrite these functions. Let m equal to vx of x comma y and n equal to vy of x comma y. That is the real and imaginary part of the functions. Real and imaginary part of the function g2 of z. So then now we have to check whether m and n satisfy the Cauchy-Riemann equations or not. So for that we check mx, that is nothing but vxx, and my is vxy. Whereas coming to the n, we have nx equal to vyx and ny equal to vyy. So now we have to check whether mx equal to ny and my equal to minus nx or not. So for that, from the given condition, the only hypothesis we have is f of z is analytic. So from that only we have to think of this problem. So since f of z is analytic, that is nothing but u plus iv is analytic. Of course, u and v has to satisfy. U and v satisfy the Cauchy-Riemann equations. and hence U and V are harmonic also, or harmonic. That means what is harmonic means U and V satisfies these kind of equations, that Laplace equation. Uxx plus Uyy equal to 0 and Vxx plus Vyy equal to 0, where Uxx is nothing but the partial derivative of U two times with respect to x, and similarly the rest. So now by using these two equations, we can check Uxx equal to minus Uyy and Vxx equal to minus Vyy. So now, so from this we can check mx is nothing but Vxx, that is equal to minus Vyy. But whereas minus Vyy is minus ny, so which is not equal to ny. So mx not equal to ny. So hence g2 of z, or can be written, can be write, we can write m and n does not satisfy the Cauchy-Riemann equations. Therefore, hence g2 of z, that is nothing but by the consideration where m is, which we assume Vx, plus I times n is Vy, is not analytic. Yes, the real and imaginary parts should satisfy the CR equation. That is the necessary condition for an analytic function. So g2 of z, sorry, g2 of z is not analytic, but whereas g1 is analytic. So from the given options, we can check g2, g1 is analytic and g2 is not analytic. So option B is correct. Answer is option B.